So now that we understand the larger purpose of evaluations and how they can be made up, now let's talk about how we might interpret what we are looking at. The first thing to remember is that evaluations are a data set. As such, you must treat them like a data set. Now, this is often a hard thing for new instructors to do, especially when they are handed a set of evaluations designed to evaluate student satisfaction or the student's emotional reaction to the class. It's really hard for new instructors to look at that data and not have an emotional reaction themselves. Even veteran instructors who receive 50 evaluations with glowing comments can still be crushed by one really negative comment sometimes. It's hard. We've all been there. But crying under our desks or even the subway ride home, been there, done that. Yeah, that won't help. So here is my advice to you. Remember that this is data. In fact, the more you treat this information as numbers and can translate, categorize, and track commentary as a set of data, the better. That way, you can better look for trends in the data and use that data to steer your choices and guide your curriculum design in the future. Now, when you receive your evaluations from your institution, included with them, you might see some numbers or statistics already generated for you on that report. And depending on the service or tool your institution uses, you might even see an explanation for what each of those numbers represent. If that explanation contradicts what I say here, of course, follow what your report says. But generally, N stands for the number or the sample size. In other words, the number of students who respond to that question. Typically, this doesn't refer to the number of students enrolled in the class, or even the number of students who filled out the evaluation, but the number of students who responded to that particular question item, as some respondents might skip certain questions. So you might see N for each individual question. Now, the mean score is the average of all scores for a set of responses. So if you have 10 people who answer question 1, the mean of that question would be the average of all 10 of those responses to that one question. Standard deviation, which is abbreviated as typically S, SD, or STD sometimes, is the distribution or dispersion of responses around the mean. Now, the standard deviation is useful in showing how consistent student responses were for any given question. A large standard deviation indicates disagreement among students. A small one indicates agreement or similarity among student responses. For example, if we go back to that 1 to 10 scale asked about the pacing of the material, and these were your scores where N was 15, meaning 15 students responded to that question, and you had a mean score of 9.6 with a standard deviation of 0.4, be thrilled. That's a great score. That means most students thought that the pacing of your material was excellent or almost excellent. And most students were in agreement about that. That's fantastic. And that's all that those numbers are communicating.